Hello everyone and welcome back. Hope you guys doing great. Today in this video we are going to look up a different type of IPv6. But before we are going to look up a different type, let me just show you how IPv6s look like. So here, as you can see, I have this IPv6. So in this in this address you can find this hexadecimal numbers. So hexadecimals mean that it start from this 0 to 9 number, and also the A starting from A to F later. So it's going to be a hexadecimal number. So as you can see, this address include this AD. As you can see, we have this F, we have this ABF, and we have this AB as well. So in IPv4 we use 32 bits of address, but in IPv6 it's 128 bytes. So bits, not bytes. So this address is actually is 8 portion. So in IPv4 we have this 4 different portion, which we called it the octet, but in IPv6 we call all of these portion as a hextet. And also IPv4 is separated by dot, but IPv6 is separating by colon. So as you can see, each of these portion is separated by this colon, and also each of these is going to be 4 bits. So for each portion we have this 1 2 3 4. So if we are going to calculate this for each one of this going to be 4, so we can get this 16 bits. So here, as you can see, for the first address that we use this 2001, so this is going to be assigned by the ISP or internet service provider, and this portion is going to be the portion that we use as subnet ID, and this portion is going to be the network ID that we use. So now we know about the IPv6s just look like this, that we know that it's going to use the hexadecimal, and also now we don't know the bits that is going to use, which is 128 bits. So we need to know the type of the IP address, that which type of IP address IPv6 is this. So we need to click on the next slide so I can show you. So here, if I'm going to click on the type of IP version 6 address, before we are going to see the different types, let me tell you that with IP version 4 we use this unicast, multicast, and broadcast. But in IPv6 there is no broadcast, only unicast is available with IPv6 addresses. So here under unicast, as you can see, we have this global unicast. So the range is going to start from this 2000:/3. And also under unicast you can find this link locals, which is going to be under this address is going to be this FE80:/10. So any address start from this FE80:/10. So you should know that this range is going to be this link local address under unicast of IPv6. And here we have this loopback, we have this unspecified. So loopback is going to be the same loopback that we used in IPv4. The loopback address for IP version 4 is 127.0.0.1. So here we have this unspecified address as well. So this unspecified address is going to start from this :/128, which is used by operating system before assigning IPv6 address. So it's not used for destination address, so it's an unspecified address in under unicast of IPv6. So we have this unique local that starts from this FC00::7. And also this embedded IPv4. We are going to look up a different this type of this unicast, which is global link local, which and also this unique local. But here embedded, let me just explain what's embedded. Embedded is used with IPv4. So as you can see, the range is :/80. So we have two type of embedded IP version 4. So the first one is IPv4 compatible IP version 6, which we add, and also the second is the IPv4 mapped IPv6. So these two is going to work with IPv6. So this is going to be available under unicast IP version 6. So under this embedded 2, so we use these two different IP, which is going to work between this is going to work between IP version 6 and IP version 4. So as I said, the one is IP version 4 compatible, and the second was IP version 4 mapped IP version 6. So here, let me just go to our next slide. And before we are going to our next slide, let me just here explain this multicast address or this. So unicast was a communication of one-to-one communication that we use, but multicast is a communication between one to multiple or a group. Or anycast is going to be the same as a multicast we use, and I will going to explain that anycast as well. But here for the multicast, we use this well-known address, which is start from this FF00::/12, and we have this transient address which is start from FF 10::/12, and for solicited node is going to be this address, which is FF02:0:0, and we have this 1FF00::/104. So this is going to be under this multicast address that we use this solicited node. So here, let me just go to this global unicast. So here, this is the structure that is going to use for the global unicast address. So unicast, global unicast address is similar to public IP version 4 address, and IP version 4 we had this IP public and private. So we use this public and private IP, so it's going to be similar just like IPv4. So it's a routable. So INA actually has assigned only 2000::/3 address to global pool. INA mean Internet Assigned Number Authority. So the global registries are assigned a range of 2001::16, means the first 3 bits cannot be changed. So here, as you can see, the 64 bits of this global unicast is going to be the provider, or is going to provide by internet service provider. So this is similar like IP version 4 that we use as a public on the internet. So this is also going to be the same that we used in IP version 6 by the internet service provider. So the global routing prefix is going to be this 45 bits, and the subnet ID that we use with this global unicast address of IPv6 is going to be the 16 bits, and also the 64 bits are going to be the host or interface ID. So this is the structure that we use with this global unicast address with IPv6. Let me just go to this second, which is this link local. Link local is only a link interface. It's a single interface, so we use this for a router. A router is only going to use it as a single interface, so you should remember that link local IPv6 is it's a link interface IP address, and also the ranges start from FE80::/10. So this is similar to IPv4. We have this IPv4 a private IP that we use. For IPv4 we use this as a single link or private link. Is going to be this 169.254.0.0/16. So in link local only, this is consist of this network ID and host ID. So the 64 bits is going to be the network ID, and the 64 bits is going to be the host ID. So here, let me just go to the next one, which is this unique local address. So this is the structure that we use with a unique local address. This address of IPv6 also similar to IPv4 private address. So the ranges start from this FC00::7. So the first FC00::8 is for assignment by global authority, and also it is same as IPv4 that we use on a public, which is not routable on a public internet. So this is going to be similar to IP version 4 private address. So in IP version 4 the range was starting from 10.0.0.0/8. So let me just go to this. As you can see, this is going to be the structure that's going to use with this unique local address. So the 16 bits for this address also going to be the subnet ID, and the 64 bits address is going to be this interface ID for this unique local address of IPv6. Let me just go to this solicited. We have this multicast address. Multicast address mean one, two, many, or a group. So the ranges actually start from this FF00, and we have this ::/8. So this multicast address and multicast, you can see it's going to be this solicited address that we use. So this is going to the solicited address is going to start from this FF02:, and it's going to look just like this. As you can see, the 104 bits is going to be this range, and after that it's going to be this 001 FF, and lower 24 bits of IPv6 address, which is going to be this 24 address. So this is going to be the address that we use for solicited node multicast address. So if we want to convert any global unicast address into this solicited node multicast address, so the lower of 24 bits of IPv6 is going to transfer from the global is going to be here. So this is how it's going to convert, and this is the structure that we used with solicited node multicast address. So let me just go to this multicast address so I can show you the for the multicast address that we use. We are going to use it with different devices with different dynamic routing protocols. As you can see, this multicast address, which is FF02::1, is used for all devices, and this FF02::2 is used for all routers, and this multicast address, which is FF02::5, is used for OSPF routers. And also here we have this FF02::6 is used for OSPF DR, and also we have this FF02::9, which is we use for rep routers, and also we have this FF02::A, which we use for EIGRP routers, and also this FF02::1:2 we use for DHCP server relay agent, and also for all DHCP server we use this FF02::1:3. And also, as you can see here, let me just, what happened to my mouse, let me just unzoom it. So here for PIM router we use this FF02::D, and for solicited node we use this FF02::1:FF. As you can see, this is going to be the solicited node, and for mobile agent we use this FF02::B. I don't know what happened to my mouse. Let me just unzoom, and also let me just fix here so we can just go to our next. So here for this IPv6 is going to be this anycast address. So anycast address is going to just work like a multicast address, but in IPv6 here, as you can see, for in these servers we use this anycast address. So in anycast IP version 6, most of the time it's used at the same address. As you can see here, we have this router and we have this server. So this is type of the anycast address. So this address is used by server 1, and also this the same address used for server 2, and also the same address used for server 3. So if any one want to communicate with one of these servers here, so the router is going to send that packet to the nearest server that is going to be accessible. So this address is actually guarantee the communications between your servers that we are going to use this anycast IPv6. So it's going to guarantee the packets that's going to send to destination. So if the router's going to see the server 2 is the nearest one, so it's going to send the data to this server 2. So let me tell you that Google is the Google server is going to use the same Anycast IPv6. So anyone want to communicate with Google server, so here the router is try to find the nearest server on the on the IPv6 of Anycast address that used with Google. So it's going to find the nearest one to reply it with the packets that was actually requested. So this is how Anycast addresses going to work in IPv6. So here let me just show you one more thing with IPv6, that in IPv6 we use the range of this address as well. So as you can see, so if you see any address starting from this 2000 or 3000, so it's going to be the global unicast. So as you can see, we have this 2000 /3. So if it's going to be 3000 /3, it still is going to be the IP version 6 address. And also we have this link local. So this link local, as you can see, is not going to change anything. It's going to be the same address. But in unique local, if you see any address starting from FC or FD, so it means it's going to be the unique local address. So as you can see, we have this FC00::7, and we have this FD00::7. So for multicast address and also for anycast address, nothing is going to be changed here. And also one more thing that is really important, so the address of the IPv6 is here it need to be shortened. So I have here examples that how we are going to shorten IPv6 address. So as you can see here, we have this address which is start from 2001 this 00:000, and we have this address. So if we want to shorten this, so simply what we can do here, for each of these zeros we can just put this 2 colon. So we have this 0, we are going to put this colon, and we have this 0, so we are going to put this colon. So we just shorted this address by using this colon. So now the computer or any device, now if you're going to use this address, so they know that this is the IP version 6, and you put this colon instead of these zeros. So this is how we are going to use this to shorten our IPv6 address. So as you can see here, we have the address, we have this, so we are still here, the other address is nothing changed. So let me just go to the second one which we use. So as you can see here, for all the only zeros that here we have, for only one portion of these zeros, you can just put 1 0 as well. You can shorten this by doing this as well. And also let me just go to this third one. So here, as you can see, I have this address which is start from 2001 colon this 001 0002 0003, and we have this 4 5 6 7. So if we want to shorten this, so simply we are going to remove. If you put this 0 here, it's not going to remove, but if it's going to be there, so you can just remove all of these 0, and you can just put this like 1 2 3 4 5 6 7 8. So let me just go to my this fourth which we have here, that we try to shorten this address as well. So for this example, as you can see, we have this address. So if you have this 000, and also you have this one and also this one, so simply you can just put this colon here, so it's going to remove all these 0. So the PC or devices now know that you have this 000 here, and we have this 000, and also the colon this 000. So you put this with 2 colon, you just made this a short address for IPv6. Okay, let me just go to my loopback address as well. So the loopback address was the same that we use with IPv4. So here, let me just bring this run so I can show you how it's going to work. So we're going to type here cmd. So if I want to ping the IP for uh, IPv4, so simply I'm going to type this 127.0.0.1. So I'm going to hit enter. So I can receive this reply packets. So it means my TCP IP is okay, so I can access this loopback address. So if I want to access this one, so simple, I'm going to type here ping, and after that colon 1. So this is going to again give me this reply packets. It means that I can access. So this is the loopback address that we use with IP version 4, and also this is going to be this loopback address for IP version 6 that we use. So hope you guys enjoy this video and you learn how to use the IPv6, and now you know the type of IPv6 that if your provider is going to provide you with this IP address, so now you know the different types. You can just have this idea that how you are going to use different types with your network or with your PC or with your device. So if you have any question, or if you have any doubt about IPv6 and their types, please let me know in the comment box of this video. So see you guys until the next video.